This is a demonstration for the problem J-6, and I'll begin with looking at figure 14. The process that we're using here is not described exactly in the descriptive geometry chapters. There are a couple of related demonstrations in here, or examples, and I'll direct your attention to figure 14. The instructions for that are on the previous page, so you'll be using true distance between a line and a point. Just to review this process, and then I'll relate it to what we're doing on the drawing problem itself. The given problem is here: fold line, a oblique line. It's not parallel in this view in the horizontal plane. It's not parallel to the fold line in the frontal plane, so it's oblique. And a point out in space, positioned here and here. To find the true distance between a line and a point, we must first find the true length of the line, which you have done many times by now. So we do that by creating a fold line parallel to a given line, and then performing the projection where we measure true distance in the adjacent plane. You can think of it as two fold lines adjacent, so 1, 2, and then measure perpendicular to the points. And here's your measurement transferred. This measurement here to A, transferred from here, and that is to R, and then to S, measured here and transferred to here. Then connecting those 2 points, creating the true length line. Then we fold perpendicular to that line to be able to see it as a point, all the while transferring the position, location of point X, also transferring it here to the secondary. When the projection is complete, you can then measure the distance between the 2 points, and you have found the true distance. This relates to our problem. Let me see. This relates to our problem here only in the way that we can turn this plane into a line. Once we have this plane as an edge view, essentially becomes a line and a point. So we have this triangle plane. Remember, you only need 3 points to create a plane, and then point P. So let's begin. We'll first start off by using our projections and our layers. So we're going to start with fold line 1 and create it. We'll draw right on top of it with ortho turned on. Let's look at our layer. Set our thickness. Okay, is at 0.7. That's good. Then we'll turn on our line weights, and we'll set our line type scale, LTS, to 0.5. And let's see. Let's make our fold line a little different color so it'll show up. Let's try red. Alright, so there it is, our fold line. Now we project between the views. We'll have to make a little correction since this is a graphic that we're tracing, and it has obviously come in just a little skewed itself. So the perpendicular lines may not match up with the points, that is the perpendicular projections. So let's go to projection 1 and we'll begin. Actually, what I want to do is create points on the object layer. So let's go to Format, change to the object layer. We'll go to Point Style. We'll make them X's. We will make them 0.06 in size, and we'll set them to absolute units. Okay, and then of course the point can be entered by PO, entered, and we'll zoom up and place it as near the center of the intersection of the lines as we can in the front view. Then we will create projection lines, and we will adjust our lines, our shape in the top view, and possibly even end up moving our point just a little bit. Alright, now projection, and we'll need to turn on our O-snap and turn on our node O-snap. And project orthographically to point C. And just do it by eye. That will work very well. It looks like it's going to match it pretty close. Let's place a point on our point down there. And you're drawing out in layout space, as you see over here. Let's see, I put that on the wrong layer, so we need to correct that. All right. Now let's draw our object lines connecting these points. Let's zoom up and see where we're at. Yeah, it's close to it. Pretty close. Alright. We do need an endpoint. There we go. Turn off my ortho. And I will need a point at the end of that projection. So what's critical in projecting in this type of little project here, the way I've set it up, is that you project far enough. So let's zoom up and make sure. I may need to stretch both of those up to where it's this depth here. Remember, you're measuring depth in this direction. So allow me to do that. I'll use stretch, and we will grab all of that. And then click on the node, and let's move up orthographically. Turn off the O snaps so it doesn't snap back to where I started. Okay, that looks good. Pretty good, I must say so myself. Now I'm going to click Save As. Put my initials on the end of it. Now we create a fold line that's parallel to one of the edges, and then, or one method would be to get this into an edge view is to create a fold line parallel, because we got to, before we can create an edge view of a surface, one of the edges needs to be true length. So to combine two steps into one, we're going to use a little trick. Let's see, I need to create the object lines for this frontal view. Object layer. Turn the O snaps back on. Ortho off. So the little trick that you can do to combine two projections or two folds into one is to create a line in this frontal view, if I'm going to project up here, that is parallel to this fold line on this surface. And when you do that, remember, any element that's parallel to a fold line, the adjacent or resulting view will create a true length line representation of that element. So let's draw a line, a new one, and we'll turn ortho on. That way it'll be parallel to my fold line, and I'm going to draw it past my object line of my surface and then trim it. Then we project this point to the horizontal view. Now it's on line BC, so I need to go past AC and move on till it crosses BC. Then I create a line that will go from this intersection point to A. Object line, line, intersection, endpoint. Now this line is the true length representation of this line. Now I can project with a fold line perpendicular to that true length line and see that line as a point and see this surface as an edge view. Bring this point along with it. When I do that, I will have a edge view of my surface, of my plane, and I'll have this point projected, and that will show me the distance between the point and the line. So to conserve file space size or file size, I'm going to stop this recording And then I'll pick up when you look at the next recording, the next video, we'll pick up right here where we left off.